In this section, we will discuss about creating real-world contracts using Solidity. We will create contracts for storing secure mailing system information or review system. In this video, we will be creating contract for reviewing system. We're going to put the reviewing system entirely into our blockchain. We will write a review which will be stored on blockchain. We will retrieve the reviews from the blockchain and more. You can manipulate reviews on normal, centralized systems. But when it comes to blockchain, it is immutable. What goes in cannot be deleted forever. When I say this, you'll be asking like, hey, in the previous video when we knew that smart contracts can be deleted or destroyed using the kill function. Well, that is specifically when you put that function into the smart contract. It doesn't have to be there in the smart contract, and if you put it, then none of the other people will believe you, since you already kept that function in the smart contract, and the contract will be always public on Ethereum. When they look at the contract, obviously the parties won't believe your reviewing system. The next one is, since it is decentralized, big parties cannot take the system down. That means generally reviewing systems, like any other systems, they are actually centralized. That means if they really want to take it down, they can. They can remove the mails. Just, it's centralized. Everything is under their control. Whereas when you put it on blockchain, it is decentralized. Everyone can see it, and there isn't a single person or entity who can actually manipulate and others can't. Can make sure that only one person per review. So we can put apply KYC, know your customer, or any type of authentication so that only one person can review it. Making reviewing products more trustworthy. Trustworthy means when it is decentralized and it is public to everyone, good products can thrive. Centralized bodies, centralized reviewing systems can actually make bad reviews impose on good products when like developing startups and all. If you give money to a centralized body, I'm saying there is a possibility they can actually put bad reviews on products who are actually competitors to others. Alright, now let's dive into writing the reviews contract. Now before we dive into the contract, this is somewhat the user interface I created for the reviewing system. I just took a small UI style from my website. It's not a big, very good interactive and style, but it serves the purpose. The first function would be obviously writing the review with the Ethereum address. Once you write the review, you will get the transaction hash. To check the review, you can check it using Ethereum address and the ID of the review. We will write the function for that and put the ID variable as well. You can like the review, count a person's review, search who wrote the reviews, take down the review. These all functions. Alright, let's dive into the code first. Alright, for this we will be using Pragma Solidity version 5.0. For the first one, we will use a mapping for mapping address to another mapping, which is uint256 to string. Now this is for storing the review with respect to address and review count from that address. We call it as reviews. Alright. Now the first mapping will actually store the address to the value, which is another mapping, which is the ID for the review and the review itself. And the next mapping which we will be using is for storing if a particular person has liked a comment for some review, not more than once. We just make sure that a person will be liking a review only once. So address is the unique key. Then another mapping which will take uint to another uint. We will call it review like. Now the reason behind this is to make sure that a person won't like a review not more than once. After this, then comes another mapping, which is an address can like a review only once, storing if that address has already liked or not. So let's put it this way. The first one, we will see that liking a comment under one's review. That'll make more sense. So the first one will be liking someone's reply or comment under someone else's review. And the third one is liking the review itself. Address to mapping, and inside the mapping, string to uint. Now let's put the name of this as liker limit. Alright, now the final mapping is for actually storing the total count, the total number of reviews. It's just like a counter, let's say it's like a counter. Well, looks like we will be needing one more mapping, one or two more. So this mapping, I would use it for a unique ID with respect to the addresses. So uint256 with the string. We will be needing plenty of mappings for different reviewing system functions. Search review, this is for that. Alright, now we came to the final mapping, and this mapping we will use it for unique review, unique ID with respect to the addresses. The first one is for searching review, unique ID for each review, and this is for unique ID for each address for the review purpose. It'll make more sense when you actually use it or see it in the function. Let's create an address which is for owner, then any count var to make sure how many reviews are getting commented. Let's put it uint256 count var. Now the first thing which we need to do is put the constructor. Doesn't take any parameters since we don't need any much. The only thing we need to make sure is that we are putting owner equal to message.sender. We have all the mapping variables for reviews like a remit and all. Now is the time for us to actually create the functions. The first function, let's say we're going to write the review. Parameter which write review takes is obviously the review itself, which is string. And what it returns is the review ID followed by the address from which the review has been written, then the boolean true or false. That's it. So once a person writes the review, we need to make sure that the respected mappings are being updated. So firstly, what we have to do is address reviewer equal to message.sender. So we're putting this address from which a person is actually writing the review. And then the first and foremost thing is you will increment the respected reviewer's address with 1. That means that person has actually wrote one review. There you go. The next thing you have to do is actually put the data into the review mapping. In case you forgot, the first one is review, which actually stores the review with the address, ID, and then the review itself. So the first one will be address, and the second one is the counter, which is this. You take that and you can put it over here, and you have to input the review. After this, you got to make sure that review like is currently 0. You have to initiate it, right? So review like, and in that reviewer is this, and then the next one would be actually your counter, this thing. Remember that this is the unique ID for all the reviews. It auto increments 1 every time. So every time you write a review, you need to make sure that you're auto incrementing the your counter at the top so that a unique ID is given to the review. We got it initiated with 0, and then count var plus plus. For search review, you need to put the count var. This is for actually searching a review function. Next comes the unique. Can you imagine how much mappings we used and how much I had to think this through to actually create a reviewing system, a simple reviewing system on blockchain? And by the way, if you really like this contract or the system, you can go ahead and check it on my GitHub. There are different projects, but this one I like the most. Alright, now once you've done all these, you gotta return 3. The first one would be the ID, as you know. The second one will be address, and the third one True, that means you have successfully written the review just for that purpose. Alright, this is a huge function which has to update a lot of mappings, but yeah, it was worthwhile. The next one is removing the review. The first one is the ID, which you have to remove. The second one will be the address of the review which is present. Let's put the name as remove address. Returns bool whether it has been removed or not. Alright, in this function, what we have to make sure is that first and foremost, if the review is present in that, then only we can remove it, right? So we need to make sure, we need to assert whether this is actually present, the review is actually present. And before that, we need to make sure that this function, when invoked, it should be invoked by the owner, not any other. Remove review, instead of removing the review, this kind of function, you can actually use a blocker method which can be accessed by only trustworthy persons. Now, the reason behind this is a reviewing system is something which you believe deep down that people are actually giving their honest review, not faking or putting a review just for money or something like that. That is something which you have to always depend on. You can't be 100% sure that people are trustworthy and 100% honest. That will be always there, and that constraint will never go. But assuming that everyone's honest and they are giving their truth, we have to go ahead. Alright, now removing the review, what you have to do is you gotta check first the owner is message.sender, and then delete reviews, address, and the remove ID. Now I'm just directly removing this review, but before this you guys have to actually write a function. I mean, not a function, a line. The line which actually makes sure that this review is actually present in the mappings. Because if it isn't present, then obviously this will get revoked and the bool written false. Alright, now once you've done that, you have to decrement the count var, obviously, and then return true. If not, if it doesn't go through, then false. Alright, these are the basic functions which will actually help in the system write review and remove review. Apart from this, I have written more functions for liking review, search review, and more. I'll be putting the code in the code files for this course.